Hello, welcome everyone to the F1 in Schools Regional Finals 2022 for the North. We are here in F1 in Schools HQ at our factory in Brighouse, where we're going to be delivering our virtual regionals to you guys, hopefully in preparation for the national finals that are going to be in person at Autosport International January 2023. So today I'm here with Amy Martin, Nelson Vale, Sam Chapman and Michael Farrell. Give everyone a wave, guys. So we're just going to go and have a look how this show is going to run today. So we're going to start off by meeting the teams. Then we're going to have a message of support from Motorsport UK. We're going to then dive into the really exciting part of the show where we've got the racing of your entry class teams, our development class teams, and finally our professional class teams, and have a look at the leaderboard and see what kind of times we've got from the track today during our show. So we're going to jump now into a real quick clip just to show what F1 Schools is all about.
What is F1 in Schools?
F1 in Schools is a global STEM challenge, working with industry partners to provide an exciting and challenging educational experience. A group of 3 to 6 students form a team, think of a name, allocate job roles, and start to design their miniature Formula One car of the future. The teams follow a systematic engineering design process to manufacture and race their cars, making sure they comply with a comprehensive set of technical regulations. To do this, they use professional CAD software, like Autodesk Fusion 360, and manufacture their car components using CNC machines. Once the cars are painted and assembled, they take to the track to race. Powered by compressed gas along a 20-metre racetrack, the cars are capable of speeds over 75 km per hour. The racing is fast and exciting, but there is more to the challenge, as it inspires learning not only in STEM subjects, but wider skills including project management, marketing, teamwork, innovation and communication. These wider skills are assessed by judges from education and industry. At competitions, the teams submit their cars and portfolios and also give a project presentation. F1 in Schools operates globally from ages 9 to 19, with teams taking part in school, regional and national level competitions. With the winners progressing at each stage, only the very best make it through to the World Finals. F1 in Schools is a life-changing experience for all involved, with many success stories of competitors who've come through F1 in Schools and have gone on to achieve significant outcomes in their lives. For some, that means working in Formula One, where the experience of F1 in Schools serves as the ideal grounding for the challenges and demands of elite-level competition.
Hi, welcome back to the studio. So, we've got a really fun-packed schedule today and we've got tons of teams from the North region. So what we're going to do is have a quick look and see who's entering the competition this year. Who are your competitors? So here's the North, and we start off with our entry class teams, into our development class and our professional class teams. So we're really looking forward to today's racing. Now's an opportunity to introduce to you some of the teams who you might be competing against from across the region.
This has been Vision Racing.
Hello, we are Idium Voltage.
Hi, we're Team On here.
Hello, we're Team Nebula.
Hi, we're Polaris Racing.
Hello, we are Lightning Tech.
Hello, we are Team Hyde Racing.
Hi, we're CHS Lightning.
Hello, we are Sigma Racing.
Hi, we are Team Cersei.
David Little.
Samuel So.
Tobias Holmes.
Well, thanks very much to the teams for sending in their intro videos. It was really nice to see some of you guys and have you introducing yourselves to the rest of the teams in this region. We've now got a very special message that we're going to share with you from Jenny Cheshiniak from Motorsport UK with some sound advice and some excellent information on how you can get into a STEM career.
Hi there, my name's Jenny Cherniak and I am the Programme Manager for Girls on Track UK, which is managed by Motorsport UK. One of my roles as Programme Manager is to organise experience days for the young schoolgirls. These experience days happen all around the country and we have 3 main goals from our days. Firstly, we want them to leave the day understanding that motorsport is not just for boys, very much a rightful place for females within the sport in all kinds of areas. The second thing we want them to learn is that motorsport is just so much more about sitting in the driving seat. There's the engineering, the mechanics, the physios, the fitness, the medical. There's so much more. And the third thing we try and encourage them to do is to give it a go. If they've not done it before, have a try, because they might love it. One way we involve F1 in schools is by inviting a competing local team to attend the event, to be positive female role models to our younger students, and to show them and teach them all about the wonderful F1 in schools programme, for them to hopefully aspire to want to follow in their footsteps when they go to secondary school. Through my years working in motorsport and in the STEM industry, it's really given me an invaluable insight into incredibly successful women that work in STEM roles. And the advice that they give and the advice that I would pass on to anyone that wants to get into STEM is just to follow your passion. If there's something you love and something you enjoy, then really pursue that as a dream. LinkedIn, asking for advice, volunteering are all fantastic ways of showing that you are committed and dedicated and that you really have a passion to follow your goals. So to finish up from me, I'd just like to wish you all the very best of luck in the competition. You've no doubt put hours and hours of extracurricular work into your project, and hopefully you've had a lot of fun on the way. So best of luck, and as I said, follow your passion, follow your dreams, and you never know what you could achieve.
Thanks for that really insightful information, Jenny. It was so useful for our teams to hear how you at Motorsport UK support the F1 in Schools competition, and actually how our F1 in Schools competitors can get into a STEM career. Thanks very much for that. We're really, really lucky that we've got some F1 in Schools alumni helping us in the studio as pundits. And Sam is just going to come in and just tell you a little bit about how F1 in Schools has helped him build a pathway into a STEM career.
Yeah, so in a very similar way to what Jenny was saying, everything that F1 in Schools does for you is useful in getting into any kind of job. So I've done 2 years of university now. However, last year I took out a year out for a year in industry, where I worked with Williams Advanced Engineering. And part of the interview process for that, I was asked to bring in something I'd made, and for that I used the design engineering portfolio that we created with F1 in Schools. So yeah, for the last year I've been working with Williams Advanced Engineering. We sort of specialise in electrification, so we make the batteries for the Formula E cars, the Extreme E cars. We also make lots of hypercars, make the Lotus Evija. There's a new Deus that just come out, 2,000 brake horsepower electric cars, so a lot of electrification generally, which is really exciting.
Amazing, thanks for that, Sam. It's absolutely amazing to hear that students from our competition F1 in Schools are making links and networking with F1 in school, with F1 teams, and starting to realise their dreams and head towards a career in F1 and motorsport. So we're going to now get ready for the racing, but before we do that, Nelson is going to talk us through how the racing actually works.
Sure thing, Tom. Pretty simple, actually. So each car will race 4 times, and each car will race 2 times out of each lane. And this is to give plenty of opportunity for teams to experience both lanes, because some say that one lane is faster than the other one. So after they've raced in 2 times in one of the lanes, they're actually going to swap lanes between race 2 and 3. And the lowest team is going to start in lane 1. The lowest team number is going to start in lane 1. And of course, we're going to have a lane swap between race 2 and race 3. And so they start lane 1, lane 2, and then they're going to swap for during race 3. But this is it, and it's all in full automatic racing, no reaction times at all. Breakages are fixed by F1 in Schools staff and judges, and in the end, the fastest compliant car wins.
Right, thanks for that, Nelson. Time for the really, really exciting part. We're going to go racing. So we're going to start off with our entry class teams, and we just wanted to sort of just make you aware that the F1 in Schools HQ is live from our factory in Brighouse. So you might hear some big bangs and some noises from drills or screwdrivers falling on the floor. That's just a normal everyday over here at F1 in Schools HQ. So if you can hear those noises in the background, don't be alarmed. People are working and manufacturing as we're filming this show and bringing it out live to you today. So what we're going to do is we're going to head over and have a look at our first 2 cars. I think they're currently being loaded at the moment onto the track by our track team. So let's have a look. Who've we got? So we've got, Amy, would you like to introduce the teams?
Yeah, sure. Today we've got Balance from St Cuthbert's Catholic High School, and then we've got Need for Speed from Thornley Salesian College. Both entry class teams, and they both look very similar. But I think Michael can probably tell us a little bit more.
Absolutely, Amy. So both the cars, as Amy says, have a lot of similarities. However, one thing that I want to point out is looking at the statistics that we're going to have for each of the cars throughout today's races. Looking at the weight, you can see that Need for Speed has a weight of 79.6 grams compared to Balance's 76.1 grams. And this weight is going to be a key feature because the mass of a car affects the acceleration. The higher the mass for a given resultant force, the lower the acceleration. The other thing to point out at this point is you'll notice at the top of the stats it says under investigation. This means that when the scrutineering team here at Brickhouse were checking the cars, they found something that didn't meet the regulations. And Nelson can maybe tell us a bit more about how this affects them in the competition.
Certainly. That means that during scrutineering process, there are certain regulations that you can definitely not fail that will potentially give you an advantage during racing. So if you fail one of those regulations, the car stays in under investigation. He races the 4 races anyway. You will get points for racing because the consequence was already taken by failing that specific regulation. But unfortunately, the consequence will be that the team will not be able to win certain awards. But still, the overall is up to any team that is competing.
Thanks, guys. That's brilliant. So I can see that we're ready out on track for the very first race of the North Regionals for 2022. So without further ado, let's head out and see the first race.
So we have Team Balance in lane 1 and Team Need for Speed in lane 2.
And Team Balance has taken that with a 1.508, but closely followed with Need for Speed at a 1.621.
Oh, that's great racing for the first race.
Yeah, I mean, it was Michael definitely predicted right, thinking that Balance are going to have the edge on Need for Speed purely because of that weight advantage, but maybe the second car might be a little bit lighter.
Yeah, well, let's find out. So, again, we're going to head out there, over to the track. I think they're ready. Let's head for the second race then.
And again, we have Team Balance in lane 1 and Need for Speed in lane 2.
And Balance have improved on their time with a 1.493. Need for Speed still in the 1.6s, but still room for improvement, I think.
A more balanced race then.
There we go.
So we just need a little bit of time for the team to switch over just into the different lanes. Did you find, Sam, that changing lanes ever made much of a difference when you were competing in F1 in Schools?
I heard it talked about every time. I mean, I was never one to look at the numbers like that because, I mean, there's so many different variables. Some teams talk about in their portfolio the uncontrollable things. So, yeah, each gas canister is going to be ever so slightly different. But, I mean, we're trying to regulate that in such a way where we refrigerate them to keep them all at the same temperature. But then, I mean, each World Finals is totally different. If it's really hot and humid, that changes the speed of... I mean, it changes the air density, but then it also changes the temperature of the gas canister and things like that. So there's so many different variables. It makes sense that you have to change. I think there's obviously always a room for a problem on one side. Not a problem. A little lip on one side of the track or something like that.
Brilliant. Thanks, Sam. Right, so they look like they're ready out on track. So the team should have changed lanes. Let's head out for race 3 then, please.
Like we mentioned before, swap lanes after race 2. So we have Need for Speed in lane 1 now and Balance in lane 2. There you go.
Yeah, and Balance takes it again with a 1.486 and Need for Speed with a 1.664. So Balance actually improving on their time. So maybe lane 2 is the faster one for Balance.
Yeah, very consistent racing for Team Balance.
Brilliant. Right, we'll just wait for the cars to come back on the track. I think we're ready outside in the factory for race 4.
Exciting to see the final race in this first set of races. Let's see who takes it.
And it's a full house for Balance. A little bit slower than they had last time. So Nelson jinxed it with their consistency. Balance with a 1.517 and Need for Speed with a 1.7.
Brilliant. So how important, Michael, is it, do you think, to get that consistent time? Was that something that was easy to achieve for you when you were competing?
It's definitely difficult to try and get a consistent time. A lot of that comes down to the manufacture of the car, so especially the wheel system. So when you connect the wheels, it's very difficult to ensure that all 4 wheels are lined up and balanced. You may have spotted in one of those races, one of the front wheels was lifting ever so slightly, suggesting maybe there's an unstraight axle hole or something like that. And also the bearings can become loose, or they may warm up during racing, and all these little things can sort of affect the consistency of the track times. So it's very variable, but it's difficult to achieve.
Thanks, Michael. So if we have a quick look at the leaderboard then, and let's see how our first 2 teams are placing as we move through the region. So we've got up there Team Balance and their fastest time with a 1.486 and Need for Speed with their fastest time of 1.621. So a marginal difference there between the 2 teams. So we're going to introduce our next team. So if we move through to our third entry class team, and Amy, would you like to introduce the team?
Yeah, so we have Team Airlight from St Cuthbert's Catholic High School, and they're all racing on their own. So that's something that's not unusual with F1 in schools. Sometimes there'll just be one person that's set up on the track on their own. I was on my own in my final World Finals racing, just me.
But it's very important to say, Tom, here that it's not racing against another team that it's the decisive factor. It's recording the 4 times of racing. So although they are racing alone, the most important is that they can actually beat the other 2 teams. Let's see.
Thanks, Nelson. Yeah, let's find out if Airlight can beat the other 2 teams. Let's head over for the first race.
Well, and of course we have in lane 1 the team and no team on lane 2, and this is also going to mean that the system is going to take just a little bit longer to give us the result, because it's just waiting to see if there's no team finishing on lane 2. So this is the reason for this slight delay on the time showing up.
Yeah, and there it is showing Airlight with 1.482, which is very quick indeed. Very good.
That's brilliant for the first race. So as the track team just pull the car back down and get it set up ready for the next race, and they've got a thumbs up, so we're ready to go. Let's head out there for the second race then.
Same situation on second race with the team racing alone on lane 1. And there they go. Let's wait just a little bit. And you're going to notice something on the second lane that it's going to say DNF. Maybe our technical experts can actually help us and say what DNF means.
Oh, you can take this one, Sam.
It was not finished, did not finish.
Did not finish,
Did not finish.
Yeah.
It's a did not finish.
Well, Airlight did finish that, and they got a 1.548.
So it's time for them to switch lanes then. Amy, did it have a psychological impact on you when you weren't racing against another team? Did it sort of limit the excitement for you, or how did it actually feel when you were just racing one lane?
I mean, I don't really think it has that big of an impact. I think it's more, I got really unlucky and I was final team of the day, racing on my own, and Crofty actually took pity on me and he pressed the trigger next to me. So although he didn't have a car, I had someone to at least race against, which was nice. So I can say that I raced against Crofty. He did beat me though, so it's not ideal.
That's brilliant. Right. So are we ready on track? Yes, it looks like we are. So we're going to head out there for the third race of this round.
Now we have no team in lane 1 and of course team in lane 2. Let's see how they do. A little bit of suspense here. Just waiting for that time to come popping in on screen. There you go.
There we go. Not as quick as the first time round. A 1.536.
Right. So, do you think that the 4 races or racing in a row, does that sometimes affect the times, Sam? Do you think, or did you find that when you were racing, did your car get faster or slower, or was it really just a luck of the draw?
I think generally it's a luck of the draw thing. I think there are elements that do improve. I think a lot of people talk about, especially with steel bearings, as Michael mentioned, bearings warm up and then they become more sort of lubricated, more, yeah, spin better, basically, so making it faster down the track. But I think there's so many small factors that really, I think you're more likely to damage your car early on and it'll get slower than it'll speed up.
Okay, brilliant. Thanks for that, Sam. Right, so I think they're ready out on track, so we can head out to the track team and get the 4th race.
And just while we're waiting for the result of this 4th race, it's important to say that entry class is one of more flexible classes, because you can actually do the cars made out of fully 3D printed, hand carved, or fully manufactured using a CNC machine.
And there we have Airlight's time of a 1.533. Not quite as close as the first one we had, but still a very good time.
Yeah. Right, so let's head over and let's just take to the leaderboard and let's see how that's placed Airlight. So if we look here, let's put Airlight in 1st position by a very, very marginal difference there. So 0.0004 faster than Balance. So we've got Airlight there at the top of the entry class, Balance there in 2nd, and Need for Speed down in 3rd. What's your thoughts on that then, Amy?
Yeah, very good. As you can see, the top 2 are both from the same high school, so I can imagine they've probably got some F1 in Schools blood going through there. Very good. But obviously there's really tight margins, so it's not like it's the end of the world if it's not the fastest car so far.
Well, that's the end of the entry class for the North region for 2022. It was brilliant. It was great to get started there and to run through those cars, and some fantastic times. So well done to the 3 teams that were involved there. So we're about to move through and go into the development class, but I know, Amy, you had a question here.
Yeah, I don't really know the difference between the entry and development class, so I think Nelson might be the best person to kind of walk us through the differences.
Well, there's certain common factors between them. Both classes use the standard wheels and axles and featherline guides, so they're mandatory to use in entry class and development class. A fundamental change is weight. So in the entry class is 65 grams, in development class is 60 grams. And that's just once you go up a class, things get a little bit difficult, like if you go to pro class, it's 50 grams. So little changes between the classes. There's a no-go zone that you basically cannot go into and cut into it, or else you're going to break a certain number of regulations, and you really want to try to avoid that. But like I was saying during racing, lots of flexibility in terms of how you can make your car in entry class. You can make it fully 3D printed, you can hand carve it, or you can use a CNC machine. But once you go up to development class, the cars that we're going to have now, you need to use a CNC machine. So looking forward for the next set of cars.
Brilliant, very exciting. So I think the cars have been moved over and changed from entry class into development class. So Amy, would you like to introduce our first 2 teams from the development class, please?
Yeah, sure. Today, first racing up for development class, we have Vision Racing, and then we have CHS Lightning. I like the look of CHS Lightning's car, very, very yellow.
It's got that kind of pineapple feel to it, hasn't it? I really like that. It's very, very interesting. So, Michael, would you like to pull out any of the statistics from this first race for us, please?
Yeah, of course. So perhaps looking at wheelbase is maybe the biggest difference between these 2 cars. So you can see that CHX Lightning has a smaller wheelbase at 90mm compared to Vision Racing with a wider wheelbase. The wheelbase can affect a number of things, but primarily it could be to do with balance, and it also can affect the frontal surface area of the car and affecting drag. If the wheels are further apart, it can affect the physics of the car going down the track.
Great, thanks, Michael.
Tom, sorry to interrupt, but one thing that is very important to say here, if you look at the weight on both cars, one of the cars was underweight, but no car will race underweight. So we ballast the cars who are underweight by the rules and regulations, so we have to put double the difference. So if your car is under 1 gram, you will take 2 grams to be able to race, but that was the weight that was registered during scrutineering. So, but no car will race underweight. They all race legal, and of course with the consequence if you are underweight.
Thanks, Nelson. So in this instance, Vision Racing's got a penalty of weight there of 2.2 grams that's been added on to make it meet the regulation. So that might be one of the reasons why it's flagged there as under investigation. But let's head out onto the track and let's find out how these 2 teams perform in the first race.
So Vision Racing in lane 1 against CH Lightning in lane 2. Let's see if they're lightning fast.
And as we can see, I think Vision took that with a 1.243 and CHS Lightning with a 1.312. As we can see, that change in weight really has affected the times compared to the entry class. So definitely getting a little bit quicker here.
Yeah. Is there normally a large difference between the times, Nelson, do you think, between entry class and development class?
Yeah, and the biggest factor for that is just the cars can be 5 grams lighter, so you immediately will be able to see that. Although, it's super easy for the team to forget about that during the assembly or during the paint process. Because it's so easy when you're painting the car, I'm sure these guys can collaborate what I'm saying, some extra grams of paint may actually make the difference for the car to be very heavy, and then you're losing some performance there.
Brilliant. Right, well, let's head out on to the track. I think they're ready out there for the second race, and let's see the times for the second round.
So again, Vision Racing in lane 1 and CH Lightning on lane 2.
And it looks like CHS Lightning has taken that with a 1.272, with Vision Racing with a 1.327. It looks like it's going to be really close between these two, with each winning 1-1. So I'm excited to see the second round.
It's fantastic racing, very, very close. Really, really good to see. So they've switched the lanes just out on the track. So I think without further ado, we can head out and check out the third race.
Now we've swapped lanes with CHS in lane 1 and Vision in lane 2. There you go.
Wow, and look how close that one is. CHS Lightning with a 1.312 and Vision Racing with a 1.333. So close, that one.
That's really, really close. And Sam, can you give us any thoughts on what's the best way to get your car as close to the target weight as possible? What was one of the main bits of advice that you could potentially give for that?
I think our target was always aim under weight, and then that weight can then be built up in painting. So the more paint you add on, shinier it gets. So that's already a benefit. But then yeah, you can paint it, weight. See, I mean, during painting, there's even some evaporation, so it does get lighter the longer you leave it. So that's always a way to do it. But then, I mean, there's even things like adding stickers on the bottom, on the back of the car, just to get those final little bits. We had some problems in painting at school in the past, where we had to paint our rear wings with a paintbrush, and Lucy, our team leader, like you say, people are dropping screwdrivers downstairs. She decided to drop the paintbrush on top of the car and wrote that car completely off. So that one threw a spanner in the works.
That sounds like a nightmare. Sounds like a nightmare. Right, I think they're ready out on track, so we can head out there for the race 4, the final race of this round.
Oh, final race. Let's see how they do. Going for Vision here.
And you've picked the wrong horse this time. CHS Lightning with a 1.379 and Vision Racing with a 1.384. So yeah, again, really close. Considering that there was a big weight difference between the two cars, well, there was before the ballast was added. I think they were really close, so very, very well designed for both of them.
Brilliant, well done, guys. So if we just go to the leaderboard now and pull that up, and let's see how the leaderboard's building up. So we can see there, Vision Racing currently number 1 with a 1.243, and then we've got CHS Lightning with a 1.272, which is incredibly close. Well done to both teams there. So let's move on to our next two teams, and Amy, would you like to introduce them?
Yep, sure. Today, next on the track, we have Team Voltage from Whitley Bay High School, and then Team Hyde Racing from Hyde High School.
Brilliant, thanks Amy. So Michael, have you got anything that you'd like to pull out from the technical stats down there?
Not so much from the stats, but looking at the pictures of the two cars, you can see that Team Hyde have a very interesting end plate design on the ends of their rear wing. They've got these triangular spikes. The idea of their end plate, of course, is if you've got a pressure difference above and below a wing, you often get air spillage going around from the high pressure to the low pressure. And so in Formula 1, we put end plates on the cars to prevent this spillage, and this helps to prevent certain vortices and helps reduce the drag of the car. So it's interesting to see Team Hyde try and apply that perhaps to their car here.
Amazing. Well, let's see if Team Hyde have applied that in the correct way and get a really quick speed. So I think we're ready out on track. So let's head there for our first race of this round.
So in lane 1 we have Team Voltage, and in lane 2 Team Hyde Racing.
And Team Voltage have just taken that with a 1.281, with Team Hyde Racing very close behind at 1.351.
Some great times again there. You can see both teams doing really, really well. And I think we're just about ready to head out and see how they perform in their second race.
Same teams in the same lanes, Voltage in lane 1, Hyde Racing in lane 2.
So there we go. As we can see, Team Hyde Racing took that one with a 1.3, and then Team Voltage with a 1.332. So Team Voltage's second car just being a little bit slower than the first one, I think.
Yeah, so what kind of things do you think could impact, Amy, on the car being a little bit slower?
So often I think with the car A and car B, a lot of the time it is down to the manufacturer. It's why some car will be a little bit heavier. Like Sam was saying, if you apply a little bit more paint to one car than the other one, then there's bound to be a weight difference. But then other than that, sometimes just in assembly, you can use a little bit more glue on one car. And when things go wrong, like when bearings get dirt trapped in them and you have to swap them out for new ones, there's a lot of things that can go wrong in that process. So that's kind of why the cars differ. But obviously in the regulations, they have to be as similar as possible.
So lots of variables.
Yeah.
A great challenge for all of our teams and designers and engineers taking part in the competition. So it looks like we're ready to head back out on track, and let's see the third race.
You can see the teams have swapped lanes now. Team Hyde on lane 1 and Team Voltage on lane 2.
And that's our closest race yet, with Team Voltage at 1.311 and Team Hyde Racing at 1.312. So 1/1000th of a difference between the two cars there.
That was close.
Yeah.
That was close. Really, really exciting stuff from both teams. So they've got one race remaining of this round. Looks like they're ready on track. So again, let's head out there and see how they perform in race 4.
Final race for this pair. I'm not gambling a winner now.
And Team Hyde Racing in lane 1 with a 1.267 and Team Voltage with a 1.317. Really good racing from both teams. Really good, I think, good competitors. They were evenly matched.
Brilliant. Well, let's check them out on the leaderboard then. So let's see where they've placed. You can see the current teams racing we've placed in orange to make them stand out for you. So you can see Team Hyde Racing have come in there in second position with a 1.267, and Team Voltage dropped there into fourth position with a 1.281. So really, really great stuff. So we're moving on to our next two teams now from the development class. And again, Amy, would you like to introduce the teams?
Yep, next up on track, we have Omnia from Whitley Bay High School, and then Celeritas from Thornley Sales and College. Both development class cars, both under investigation, it is worth noting.
Some really cool colours that you can see there again on the two teams. Did it make much of a difference, Amy, to you when you were coming up with the colours and the theme for your team?
Yeah, I always stand by my F1 in Schools car is the prettiest F1 in Schools car there has been. So yeah, I'm a big fan of picking the nicest colours.
I think the Celeritas has got that kind of screwdriver feel, that orange and black. It looks very kind of toolbox, and then we've got that really shiny gold kind of vibe on the Omnia car, which looks really exciting. So we'll head out onto the track and let's see how they perform in their first race.
Well, this time we have Team Omnia in lane 1, Team Celeritas in lane 2.
And then we have Celeritas with a 1.284, with Omnia at 1.425. I'd be interested to see what Sam and Michael think about why there's such a big difference between these two cars in their times.
Yeah, I mean, it's a very interesting question. I feel like the design philosophy is totally different in both of them. I think it's interesting when you look at the rear wing of the yellow car, Celeritas, I believe. I'm not completely sure of the philosophy behind that rear wing. I think a more vertical rear wing isn't going to be producing downforce or lift, which I think makes sense for an F1 in Schools car. I don't think you want downforce. That's going to add friction to the wheels. I don't think you want too much lift either, because then it's going to be hovering. It's not going to be very stable. That to me more looks like a dart, as the sort of flight of a dart that goes straight down the track, which I think is a very solid idea.
There was quite also a bit of weight difference there between the two teams. And one fun fact is that when teams are trying to get the cars up to weight, sometimes they think outside of the box, so they have the car just underweight, so they may just get a screwdriver and get some screws underneath the car and then fail scrutineering because it's an undefined feature. So teams get clever, but being clever, you need to just look at the regulations and see what you can do. And like some tips that we've given them before, weight potentially every single component before we go with the final paint process to get it really close to those 60 grams here in development class.
So it's really, really important that as teams move through their challenge that they definitely make sure that they're reading the regulations and making sure that you've got no undefined features as part of that process. So I think we're ready out on track, so let's head out there and let's see race 2.
And that was a very close one, with Team Omnia taking it with a 1.315 and Celeritas with a 1.317. So when I was saying that there was a big time difference between the two cars, I was wrong. Clearly one of the cars is just a little bit faster than the other there.
Thanks, Amy. Yeah, we sometimes see the 1.2s, the 1.3s. What kind of times do you see, Nelson? What would you say is one of the faster times that you see of a development class car?
Well, it really depends on the cars. How it's actually being assembled and designed. You may have a car that's amazingly designed and you think it's going to be a super fast car, but the assembly process is actually done incorrectly. So if you put too much pressure on the axle, these ones don't have bearings, but a little bit more pressure on the axle against the wheel will make the wheels not spin as much. So you can actually see from one race to the other the car gaining performance because that wheel may be becoming a little bit more loose. It's all about one of that team member that prepares the car to go to racing, and that's one of the reasons why we miss the students so much here with us. But it is what it is. We've done our best to prepare the cars to go racing. Yeah. But yeah, it depends on the manufacturer, depending on the design. But these ones are looking really good.
Thanks for your insight there, Nelson. So I think they're ready out on track now. They've switched lanes, and we're going to head straight into race 3.
So of course now we've swapped lanes, with Team Celeritas in lane 1 and Team Omnia in lane 2.
That was another close one, with Team Celeritas taking a 1.298 with Omnia taking a 1.35.
Really close racing again there from these two teams, battling it out really, really well out there on the racetrack. So they've got one final race left, and I can see just out there that the cars are just about ready. The new canister's been loaded. And yeah, we can head out onto the track for race 4.
It's been very quiet in the studio. I think we're going to need to cheer for some teams. I'm going to go Team Omnia. Let's go. Win this one. Come on.
Nelson, you're really bad luck. Team Celeritas wins with a 1.297 and Omnia with a 1.391. So I wonder where that kind of put them on the leaderboard.
Let's have a look and find out then, Amy.
I tried Team Omnia.
Yeah, so Team Omnia got the curse of the presenter there from Nelson, so you can blame him for that one. And so Celeritas down there in 5th position with a 1.284, not too far off from the other members of the development class. And Omnia, again, not too far off, just down there in 6th position with a 1.315. So we've got a couple more teams to introduce to the development class, so we'll just pull their stats up on screen. Amy, if you'd like to do the honours.
So next up, we have Team Nebula and we have Team, I might have mispronounced this, McTech? Like McDonald's?
Like McDonald's or McLovin.
McTech.
Go McTech.
They are looking lovely, that car.
So again, both cars flagging up the under investigation, as we mentioned before. It just means there might be a slight error or a slight misdimension as part of their scrutineering process. Michael and Sam, have you got anything that you'd like to pull out that really stands out on the stats there?
Yeah, I think yet again the weight difference is going to play a big part in it. I think you can tell from the length and the well, I mean the wheelbase isn't going to make a huge difference to the weight, but the length especially being 25 millimeters longer is going to add a lot of weight. So a lot of teams want to go for a longer car, a long sort of more gentle profile, maybe guiding the air a bit better. But if it's adding extra weight, then I would always say a lighter car is better than an aerodynamic car for F1 schools.
Thanks for your insight there, Sam. So the cars are ready and loaded, so let's head out onto the track for the first race.
Oh, there they are. Team Nebula in lane 1, Team McTech in lane 2.
And Nebula takes that one with a 1.277, with McTech with a 1.338. So that short bullet-like profile that Nebula's gone for, kind of really helping them there, I think.
Yeah, and you can see them breaking into the 1.2 second time zone, which seems to be where the majority of our teams are placing at the moment. So let's see if McTech can break that as well. And let's head out on track. I think we're ready for race 2.
Second race, let's see if the performance will get better. Team Nebula lane 1, McTech lane 2.
And another really close race with Nebula taking that one as well with a 1.314 and McTech with a 1.319.
Really close, really close. So as the track team are switching the cars over, Nelson, if we were in person right now, what would you see the track team doing?
So the track team is basically going to have to unhook the car from the tether line. Be very careful taking that tether line up to the tether line, guys, not to damage the car or anything. So our track team is very, very experienced. Swapping the cars to the other lane, tethering the line again and getting them ready to race with fresh set of canisters straight out of the fridge. They come from controlled temperature for it to be the same for every single team until it's ready to go.
Perfect. Thanks for that, Nelson. Well, it looks like they've just done that outside on the track, so we're ready to head straight in for race 3.
Race 3 with McTech in lane 1 now and Nebula in lane 2. There you go.
Nebula still reaping the benefits of that shorter car design with a 1.317 and McTech with a 1.339.
So only one time so far that's broken beneath the 1.3 seconds mark there. So hopefully in race 4, you never know, we might get both teams breaking that time. So let's head out onto track. I think they're ready there for race 4.
Race 4 then. Let's see who will take this final race. That was close.
We have Nebula going 4 for 4 with a 1.284, but very close behind McTech with a 1.287.
Wow, that was some great racing from Nebula and McTech, and we've got Nebula placing in 4th position with a 1.277, and McTech placing in there in 7th position with a 1.287. So we're just going to move over to our next race in development class, and that's going to be Team Flow. I'm sorry, Amy, I've stolen your thunder and introduced the team there on my own. But it's got that lovely kind of lime feel to the car. Really, really like that. Michael and Sam, is there anything that you'd like to pull out from the stats there?
Yeah, just one thing. Once again, we've got a car that's slightly underweight. So we've got a mass of 59.6 grams, which is, of course, below that 60-gram regulation. What this means, as we saw earlier in the North competition, is that extra ballast, extra weight has to be added to the car so that it's fair for all teams.
Brilliant, thanks for that, Michael. Well, let's find out how that affects Team Flow as they go down the track for their first race.
Well, first race then in lane 1, Team Flow against no team in lane 2. There they go. And just to make everyone aware that we're just going to have to wait a little bit for the time to be on screen.
And there we have Flow in lane 1 with a 1.445. Sorry, there might be some noises there, people with their screwdrivers making all sorts of noises.
And that's part of the factory, as we mentioned. F1 in Schools HQ is recording live from Brig House, which is our factory, and that's why you can hear all of those noises in the background there.
They're busy making tracks for all around the world.
Absolutely. So I think we're ready out on track there, and we're going to have a look how Flow perform in race 2.
Right, so race 2. Team Flow in lane 1, in lane 2, no team.
And after just a brief wait, Flow has improved their time by quite a lot, so 1.277. So really good time for Flow that time. It's also good to mention that none of the teams have really suffered any breakages so far, so no one's had to get their screwdrivers out to make sure that the rear wings are back on. So yeah, really good job from all the teams.
And how does that affect, Nelson, the team's times, do you think, if there is breakages?
Well, any breakages mess with the integrity of the car itself, doesn't it? I mean, these guys can actually say it better than me, but they align the wings in a certain way. If they break, you're never going to get it into the exact same position, and there's always going to be a little bit of super glue where they don't want it. Lots and lots of stories of super glue entering bearings, not in this class, but yeah, no one wants to actually fix the car. They hope that they can finish the 4 races. So yeah, I think we'll be able to see this car ending the races with no issues.
Brilliant. Right, well, I think they look like they're ready out on track, and Team Flow has been switched on to lane 2. So let's head out to the track and see how it performs.
Our brilliant track team has swapped lanes. They've been working really hard, Tom. We're going to need to praise them in the end. And again, we're just waiting for the system to detect there's no team in lane 2. Should be getting the time now, Amy.
Yeah, and there we have it. Flow with a 1.278. So just 1/1000th slower than the last time they posted. So really consistent, really good job.
Really consistent. I saw there at the start of this stream for the race, Sam, that one of the wheels was slightly twisted and up on the track. Was that going to have an impact on these times?
It's hard to say what sort of effect that'll have on the wheel touching the ground will have on the race. I mean, it's just going to add extra friction if there's 4 wheels on compared to 3. But that's why the regulations say there has to be 4 on the ground. It's a limiting factor. So that'll be why the car. Well, one of the reasons potentially why the car may be under investigation. But it does sort of imply that there are a few areas, and there has been on other teams as well, a few areas where the car manufacturer has clearly not exactly matched the CAD. So the CAD, you could design a car in CAD that's 210 millimeters long, but as you come to manufacture it, it could end up being a little bit longer than that due to glue gaps and things like that. So it's important for teams to be aware of the fact that CAD doesn't always equal reality sometimes.
Brilliant. Thanks for that insight, Sam. So it looks like we're ready on track, and it's the 4th and final race for Team Flow. Let's head out there.
Final race. Come on, Team Flow. Oh no, I'm going to jinx it. No, I'm not. Race 4. It's always sad when it's the last race for a team.
Yeah, I mean, they've all worked so hard, but Nelson actually did a really good job there with predicting, and Flow ended up with a 1.262, which is their best time yet. That's
amazing. And we've got the leaderboard up there already, so we can see that Team Flow there in orange have placed in 2nd position with that 1.262. So that 4th race really has boosted them up to the near to the top of the leaderboard. And we saw a really consistent racing from Team Flow, so really well done. I think we're ready now to move on to our final race of the development class. And Amy, would you like to introduce the teams?
Yeah, for our final 2 races, we have Celerity and we have Polaris Racing.
So there's a fair few stats there as well, these final 2 cars. They look pretty snazzy to me. Sam and Michael, if you'd like to take anything from the stats there?
Yeah, I think, again, most importantly, weight looks pretty spot on from both teams there. I think 60.0 is exactly what everyone's aiming for. 60.4 is not far off. And I think that's especially impressive from Celerity there, because it is a long car. It's towards the 210 mil limit. It's wider than Polaris. It's shorter. Maybe that's where all the weight saving is coming from, having a car much lower to the ground.
Brilliant. Thanks, that's Sam. Right. Well, let's see if that does have an impact on the race, and let's head out to the track for race 1.
Right, so this is race 1 against Celerity in lane 1, Polaris in lane 2.
And Celerity took that with a 1.223, with Polaris Racing at 1.4. It's a little bit slower than we've had today, but hopefully car number 2 might be a little bit quicker.
Let's hope for that. Really fast time there for Celerity. So let's head straight out and see what happens in race 2.
Race 2, teams in the same lanes. Celerity, lane 1, Polaris, lane 2.
And Celerity take that one again with a 1.259, with Polaris Racing going a little bit quicker with a 1.399.
Really consistent again there from Celerity. Both times under 1.3 seconds, which will be placing them hopefully quite high up the leaderboard, with Polaris just slightly slower there for 1.397, but beating their previous time, which is really, really good to see. So the track team are working nice and hard outside. You can see they've just loaded the cartridges. So we are ready to hit out onto the track for race 3.
Race 3, now in the opposite lanes, Polaris in lane 1, Celerity in lane 2.
And Celerity proving to be the quicker car once again with a 1.248, which is very close to the fastest time we've had so far in the development class. Polaris going a little bit quicker with a 1.397.
And I noticed that that was exactly the same time as what they got in race 3, so nice consistency from Polaris Racing, so well done there. So we've got the last race of our development class now, so we've got race 4. Let's head out onto the track and see what happens.
Last race in development class. Polaris, lane 1, Celerity, lane 2.
And Celerity go 4 for 4 with a 1.237, with Polaris Racing going a lot quicker with a 1.242.
Wow, it's a great finish there from Polaris Racing. Really, really fast compared to their previous times. It was nice to see. And then obviously their Celerity taking all 4 races. So let's check out the final leaderboard for development class and let's see where these teams are placed. Wow, so you can see that Team Celerity have gone straight in position 1 with the 1.223, and Polaris Racing have gone in second with that final race time of 1.242. So both going straight to the top of the leaderboard. So if we go and have a look now at the overall leaderboard, the final part there, you can see we've confirmed that Celerity in place 1, Polaris in place 2, Vision in 3, Flow in 4, Team Hyde Racing in 5, CHS Lightning in 6, Nebula in 7, Team Voltage in 8, Celeritis in 9, McTech in 10 and Omnia in 11. So I think it was a fantastic round of development racing. What do you think, Amy?
Yeah, really close between all the teams. As you can see that there was like less than 1.10 separating, 1.1 separating all of them. So yeah, really close racing.
Really, really good racing. So we're just going to actually now head over to our technical pundits, Michael and Sam, who are going to just talk through some technical information that might help support you as you move forwards in your development, or if you move up from entry development, or if you move from development to professional, something that you might want to bring into your design process. Over to you guys.
Yeah, thanks. Something that we wanted to draw attention to actually was the wings regulation. We found during our time there was a lot of research had to go into, I mean, even just what the vocab actually means. So wing chord, thickness makes a little bit more sense, but then there's a lot when you start delving into what airfoils actually are. There's a lot of things that maybe are worth looking at. So in Formula 1, the reason for having a wing is to increase the downforce, meaning you can have faster cornering, and also to reduce the drag. Drag is a negative side effect to having a rear wing, so the F1 teams want to reduce this drag as much as possible.
Here we've got a picture, sort of a large picture, explaining some of the terminology that we use for airfoils. Most teams, from their design work and F1 skills, will be very familiar with a lot of this terminology. Of course, the chord length is something that's prescribed by regulation, both in F1 schools and in real Formula 1. As is thickness. An important feature to think about though for Formula 1 is the angle of attack. Of course, in Formula 1, as Sam said, the idea of a wing is to produce downforce. We'll discuss a bit later on whether this is actually the same for F1 in schools, and we'll maybe decide it's not. But in real Formula 1, the aim is often to produce as much downforce as possible, of course trying to reduce the drag alongside that. And angle of attack is one of the ways that we do this. So in general, by increasing the angle of attack, you can increase the drag, the downforce that you produce. However, you may think, let's just ramp that angle of attack up as large as you can. But there's a problem with this. So when you increase angle of attack too much, what you get is you get something called stall. So you get separation, the flow no longer remains attached to the wing, and this reduces the downforce it can produce. You can see in this, CFD simulation here, you can see how this angle of attack has become too large, and so we get separation towards the trailing edge of the wing. This has impact on the downforce, and it also can affect the drag due to the vortices and swirling that we get behind the wing. So, what do Formula 1 teams do to maybe try and rectify this? What you'll see on Formula 1 cars is we often have two elements. And there's a lot of different explanations for why this two-element design may work. But by getting flow, by having a second element, we can help flow remain attached for longer. And if we look at the CFD simulation now, adding a second element, you can see how even though the overall angle of attack of the two wings is the same, the flow remains attached. And so this results in greater downforce. But going back to the reasons why Formula 1 cars had extra downforce, or wanted downforce, was to do faster cornering. How does that compare for F1 in schools?
Well, I think something important for F1 in schools is it's a drag race. Drag cars have downforce, but only on the rear wheels really, because they want to get the traction on the wheels to cause a rotation to get the car moving. However, F1 in schools cars are powered almost just directly from the back. There's no power going into the wheels. So therefore, you don't actually need downforce. You don't need downforce for the front wheels for turning. You don't need downforce for the rear wheels for putting the power to the ground. So therefore, I think downforce is only going to be causing extra friction that the cars don't actually need. Reducing the drag is therefore the more important thing to get the faster straight line speed. This could be by ensuring that the angle of attack is, nothing would mean that there's absolutely no downforce. However, it could even be negative the other way, creating lift in the same way as an aircraft does. Lift, you don't want to, again, get too much. It'll act exactly the same as this diagram the other way, and there'll be separation. But also, too much lift is going to make the car unstable. So, in our opinion, we were always aiming for absolutely no downforce, no lift, just straight down, using the wings to sort of guide the car straight down the track. But lots of teams have differing opinions about it, so it's interesting to see what each team thinks.
Amazing, thank you for that. I think that hopefully you can take something like that, you can bring it into your portfolios, your design process, the next time you compete, or maybe if you make it through to our national finals, it might be something that you try and adjust and develop. So we're going to now move to the last segment of the North Regional, and it's the professional class. Nelson, can you tell us a little bit more about the difference between development and professional, please?
Well, basically in professional, you can go all in. You can basically customize every single component on your car. So while in development class you have the no-go zone, in professional class you have the virtual cargo. So it's basically you need to make sure that you have the virtual cargo in professional class, while I cannot really go into the no-go zone. So it makes the students just think differently. And now they can make their own wheels and even include bearings, so really exciting.
Really, really exciting. Great stuff. Right, Amy, you ready to introduce the first two teams from our professional class?
Yeah, I'm really excited to see what these two teams can do. So first up, we have Sigma Racing, and then we also have Ulmaz 2.
So, two new cars, professional. You can see the professional class, they look quite different to what we see in the development class. What can our technical pundits tell us about these two cars then?
Yeah, well, I was looking into the professional class cars before we started this, and I thought Sigma Racing's was the prettiest car that I'd seen amongst all regional finals. I think the engineering that's gone into it's really impressive. The sort of raised front wing with some aerodynamic features beneath that is something that was very common at World Finals this year, which we were attending, and I believe they actually mentioned that was one of the things that they followed. They were also very interesting in the way that they've developed the paint, or they've tested paints on their car. They decided to spray paint a model block, a few model blocks with different amounts of paint on each time, and then lay them on a wooden plank, and then raise the wooden plank to see at what point that would begin to slide. In theory, meaning that's the lowest level of friction, which is therefore going to cut through the air better.
Amazing stuff, brilliant, sounds fantastic. So we are ready on track, so let's head out for the first race between these two cars.
So lane 1, Sigma Racing, lane 2, Ulmaz 2.
And that's our first professional class race finished, with Sigma Racing winning with a 1.236 and Almost 2 with a 1.276.
It's nice to see two pretty quick times there for a professional class. And hopefully they're going to be consistent throughout the 4 races. So without further ado, I think they're ready and just loading the canisters out on track. Let's head out there for the second race.
Second race, we have again in lane 1 the beautiful Sigma car and a more approach of unfinished on Almost 2.
And that means Sigma's gone the fastest we have had today with a 1.206, with Almost 2 with a 1.226. Still a very quick time.
Wow, that was a fast time. So in terms of the times that we expect to see, Amy, from your experience, how fast might you expect a professional class car to go?
You're asking the wrong person if you want a fast car, Tom. We never did the fastest, Nelson can agree. But it kind of varies a lot of the time with regulation changes, kind of like how current Formula 1 changes with regulations. So there can be a variety of times, but I never think racing is the most important part. I always like the strong, sturdy portfolios, definitely.
Thanks, Amy. Right, well, I think they have switched lanes and loaded the canisters, so again, we're ready to head out, and let's see the third race.
Third race, now the teams have swapped lanes with Almost 2 in lane 1 and Sigma Racing in lane 2.
Well, I could definitely have used some tips from Sigma Racing because they've gone even quicker with a 1.183, with Almost 2 with a 1.347.
So Almost 2 going a little bit slower than their first race there, and Sigma Racing going even faster and breaking the 1.2 second barrier there, which was really cool to see. So we've got one final race between these two pairings. The cars are down the track and the canisters are loaded. Let's head out onto track for race 4.
Race 4. Now, the question is, how fast will Sigma be able to go? Come on, Almost.
Sigma didn't go as quick as they did last time round, but still quick with a 1.229 and a little bit quicker for Almost with a 1.265.
Still a great effort.
Brilliant racing from both teams there. And we see the leaderboard, the first part of it, you can see there Sigma Racing with their 1.183, and we've got Almost with the 1.226, just slightly slower in second position. So we'll move on to the next set of teams. Amy, if you'd like to introduce them.
Yeah, that race definitely got me excited for the rest of the professional class. So we have Cirque Racing and Sigma Racing, and that's not Deja Vu, that's just a second Sigma Racing we've got.
Yeah, so look out for the red car there for Sigma Racing, and we've also put the school initials just to help you determine which cars which when we do get to the leaderboard. So this Sigma Racing is out of Sandbach High School. So we'll look for those when we head back to the leaderboard a little bit later. Sam and Michael, have you got anything interesting that you'd like to pull out from these two cars?
So we're now, of course, in the professional class, and that means that weight boundary has gone down again. So entry was 65 grams, development was 60 grams, and now the minimum weight is down to 50 grams. As you can see, Sigma Racing have got this much closer to that 50 gram mark than Cirque Racing, and so I suspect we will see a slightly slower time from Cirque on track, but who knows, let's see.
Who knows, absolutely, Michael. Let's head out on track for the first race.
So lane 1, lane 2. Who do you think will win this one, Amy?
I'd have to put money on Sigma.
It's almost 20 grams, isn't it?
And there we have it. Sigma with an amazing time of 1.101, with Cirque, as we predicted, going a little bit slower with a 1.571. But if that weight limit did go down a little bit, then I think they might have a better chance.
Yeah, they seem to have designed a good car, but just that weight's really sort of pulled them back a little bit. Potentially, it might be something for them to look at in terms of developing if they're going to enter again next year. So let's head out again and let's see actually if Cirque can improve with race 2.
Right, we have Cirque in lane 1 and Sigma Racing in lane 2.
And there we have Sigma again with a very quick time of 1.16. Cirque with a 1.559. So a little bit quicker, I think, but still could use some improvement.
Absolutely. So, obviously, as the teams are switching, we're getting some really, really fast times there from Sigma Racing, under 1.2, really consistent. So, clearly, the assembly and the manufacture's gone really, really well. Is there one key thing from the assembly, Sam or Michael, that you think is really important for the team to think about?
I think especially the paint, as we can see now. I think in the first race with Ulma 2 had a almost totally unfinished car. I think considering the size of that car, the fact that it was down, I think it was 52, 53 grams, was totally due to the fact it was unpainted. And actually, while I was at work, I was hearing rumours from Williams F1, and apparently they were trying to get their weight down, and to do that they took all the paint off their car. So you can see now on the car where it used to be dark blue, it's carbon, but a lot of the engineers were pushing the team to say, we don't need any blue, let's just have a full black carbon car. And obviously that was denied for brand identity, but they were pushing for it, so it's the same as what Ulma have done.
Really, really cool inside knowledge as well that we can get there. Let's hope that you've not broken any rules by sharing that information with us and with the teams. Right, I think the track are ready and the team have switched lanes, so let's head out to see the third race.
Right, now Sigma in lane 1, Circa in lane 2. Well, I guess that if they share a little bit of weight, the car would be way more competitive. So that's a goal.
Yeah, and they've done really well in this race with a little bit quicker with a 1.499, Sigma with a 1.25. So not as quick as that first run, but still consistent from both teams.
So Sigma not as quick, but Circa actually improving the time each time, which is nice to see. So we've got one final race between this pairing. I think they're ready out on track, the canisters loaders. Let's head out and see race 4.
Race 4, final race for these two pairs. Let's see.
And there we have Sigma with a 1.169, Circa going a little bit quicker with a 1.449.
Really good times posted there again. So let's see how that places them into the leaderboard. So we've got Sigma Racing from Sandbach High School have just pipped Sigma Racing from the Royal Grammar School in Newcastle with a 1.101, and you can see their Circa Racing coming in there in 4th position with a 1.449. So we've got another race lined up for you in the professional class. Would you like to introduce the team, Amy?
Yep, so we have another final solo racer from Suffragettes. I actually picked this name out because I think this is one of my favourite names of the regionals so far. So yeah, really excited to see how they perform.
Nice, cool colour as well there. All purple, we've not seen that yet. So over to the technical pundits, what can you see there?
Looking at the wheels, it looks like Suffragettes have possibly gone and used the standard issue wheels that we've seen earlier on in the competition with our entry and development class. And this is quite a good way of doing it if you maybe are struggling on time or if you have limited manufacturing possibilities. But it often comes at the cost of the weight. So of course those first two categories have a higher minimum weight, and so those wheels are suitable. But perhaps when we get onto the professional class, looking at alternative ways of manufacturing the wheels to help reduce weight could be a way to go.
So had they been a development class car, they would have been pretty much on the money with a 60.1 grams there. So potentially a slower time here then for Suffragettes as they go onto the track, but let's find out as they head into the first race.
First race, Suffragettes in lane 1. You can even see the approach on the wings, that it's very development class. You know, teams go through a development stage, and the decision of going from development to pro class, finding the right moment to go to a different class. It's tricky, but they've made their choice and they're in pro class.
And not a bad time from Suffragettes either, with a 1.246.
Relatively fast there, so good manufacture on the car. Probably everything's working nice and smoothly. And you know they've come in with that 1.246, which is a great time. So let's see if they can improve their times, or let's see if the time gets a little bit slower as we move back to the track for race 2.
While we wait for the time on race 2, it's important to say that the regulations are quite different from development to professional. Now, does those wings actually comply with the professional class regulations? Something for our viewers back home to go and research a bit.
And Suffragettes have posted a time of a 1.382. So a little bit slower than before, but still a good time.
Yeah, good time, a little bit slower. Just touching on what Nelson just mentioned before as suffragettes are moving lanes. Sam, what is it about the regulations for the wings that is a big difference that you notice between development and professional?
I think especially in the last few years, the rear wing regulations changed massively. So it's now you can't have sort of like a broken rear wing where there's two segments that add up the length. You have to add up one whole section. So you'll see a lot of the cars have a rear wing above the height of the canister. I think that was especially weird for us coming back, having competed with the previous regulations. There was a lot of changes, and there's always more changes coming in. I think next year is probably going to be some big change, and then the year after that. So when I was competing as design engineer, it was spend a year working to a set of regulations, memorising them, and then trying to unremember that for the next year was always something difficult.
And Amy, does that keep it nice and exciting for you in terms of these changes, keeping it fresh because you competed for quite a few years?
Yeah, so it's I think my favourite part about coming back to F1 in schools is seeing how much the cars have kind of developed over the years, because I last competed in 2016, so the cars that I was designing are very different to the cars that I see racing now. Mine weren't compliant back then either, so I don't know if mine would be compliant now.
Looks like you could learn a thing or two from some of these teams then, Amy. Right, the team has changed, suffragettes have changed lanes, so let's head out on track and see how they perform this time.
Now, race number 3 with the suffragettes, as you can notice, on lane 2. And while we wait, my word of wisdom is read the regulations very carefully.
Very carefully. And then we have suffragettes in lane 2 with a 1.365.
I just want to mention here as we're doing it that I love the noise of the canisters as the car fires out of the start gate. It's just an absolutely brilliant sound, and you could hear the suffragettes rolling into the finish brushes. It just sounds so nice. Maybe I'm a bit strange. So let's move on now. I think the suffragettes, they've got their last race, the canisters loaded, and they're ready to go. Let's head out on track.
Race 4, suffragettes. Let's see how they do. But I also love the sound of the canisters coming off, Tom, and that. Love it. I even have a joke with that. I'll tell it in a different show.
This is Nelson has us in suspense for that. Suffragettes with a 1.425.
So a little bit slower there. I think their times did progressively get a little bit slower as they went through the racing schedule there. So let's have a look how the suffragettes place. And I think that was the final round of our professional class as well. So we can see here that the suffragettes have placed in 4th position with 1.246 that first time that they reached there. So we got Sigma Racing from Sandbach High School in place 1, Sigma Racing from Royal Grammar School in place 2, Ulmus 2 in place 3, the Suffragettes in place 4, and Circa in place 5. So we've got left now chance just to have a look at how all the teams fit in the different classes, because what's nice to see is, are you ready to move to the next class? Are you an entry class team that's ready to go into development? Are you a development class team that's ready to go into a pro? And maybe do you need to look as a professional team at trying to see if you can develop? So we'll just have a look at the final leaderboard, and let's see the entire region from the north ranked from 1 to 19. So we can see there, as we expected, both Sigma Racing teams in 1 and 2 from the pro class. But what's really interesting there, Amy, is Celerity in place 3 as a development class team.
Yeah, they've done a really good job, I think, getting that high on the leaderboard, definitely splitting the pro class top 3.
Yeah, and I mean, it's natural to see the entry classes down there at the bottom because of the regulations and the weights, but with their times, they're just not that far off some of the development teams. So definitely be good to see those schools and those teams developing further in the development class and moving forwards. So really, really, really well done to all of our teams. I think everyone's done an absolutely fantastic job, and you know, it was fantastic to see. Such great engineering, such great cars on show, racing down our track. You know, it's been a fantastic day from the north, from our region. Any highlights from you, Nelson?
Well, I think it's important to say that, I mean, racing looked great, but it's not just about racing. There's a lot going on in the background, Tom, with judges judging portfolios and verbal presentations and pit display videos. A lot of things going on in the background to get everything into a final score sheet for us to know who is the best for the award show.
Brilliant stuff, thanks Nelson. Yeah, it's definitely important to remember that. And your award show, that's going to be live tomorrow. So make sure you tune in for that to find out who's going to make it from the North to the national finals January 2023. So that just leaves me now to say thank you to Michael, thank you to Sam, thank you to Nelson, thank you to Amy, and thank you to you all from myself, Tom, here at F1 in Schools HQ in Brickhouse.